In this lesson, we'll be looking at what's called solving right triangles. What will be new in this lesson is how to set up a trig equation, in this case an inverse trig equation, to find a missing angle in the triangle. We've been finding missing sides with regular trig equations. We'll see what an inverse trig equation looks like, or inverse trig functions. So you'll be able to use trig ratios to find side lengths and angles of right triangles. So let's look at our first note here. Now on your note pages it shows the inverse trig ratios this way. I want to show you a different way, so I'd like you to either get a scratch paper or on the back of your notes. We'll be looking at this triangle right here. But to explain the difference between the regular trig functions over here on the left, sine, cosine, and tangent, and what's called their inverse trig functions over here on the right, denoted with the little -1. It looks like a power. It's not really a power. It just means inverse. Okay, so to explain these, the regular trig functions, we've set up equations like this, where the sine of an angle equals the ratio of the side opposite over hypotenuse, or cosine adjacent over hypotenuse. The input was the angle measure. The output was the ratio of these sides. You know, we did it with our calculator. You know, you saw that if I bring up this calculator, that when I hit the sine button and I put in the measure of an angle like 30 degrees, whoops, I better check and make sure I'm in degrees. Yep, I am. So make sure yours are today. The output is the ratio of sides, but not as a fraction with the calculator, as a decimal. So we got 0.5, but the input was the angle, the output was the ratio as a fraction or a decimal. Now what's different is that with the inverses, the input and the output switch. For the inverse sine, the input is the ratio of sides as a fraction or a decimal. You know, we usually set them as these fractions, the side opposite over the hypotenuse. If I put that into the calculator or into the inverse sine function, what it outputs is the measure of the angle. Okay? So I think this is a better way to describe it. So we use these to find angles when we know these two sides, you know, and we'll see how this works. Whereas we use the regular trig functions to set up an equation to solve for a side, we use the inverse to set up an equation to solve for the angle, and you'll see how easy it is. All right, so let's look at our first example here. Just using the right triangle above to fill in missing links to complete the inverse trigonometric ratio, or an equation. So if I wanted to solve for, here they got the measure of angle A, I'd want to put in the ratio of sides. What? For sine, for inverse sine, I need to put in the same sides I would for regular sine. It is the side opposite over the hypotenuse. And you can see if we label these sides with respect to angle A, I forget if I did it in this video or not. No. So let's see, here's the hypotenuse. I'll just put an H for hypotenuse. With respect to angle A, over here would be the opposite, side BC. And that leaves this as adjacent, the A here, adjacent. Okay? So again, what do I want to input into inverse sine? The opposite side, which is BC, they've got it there for you, over the hypotenuse, which is called AB or BA. So this is for your notes. And if I input that into the inverse sine, I'm going to get the measure of that angle if I knew these side lengths. You'll see how. Conversely, maybe we don't know the opposite side. Maybe we know the adjacent and the hypotenuse. So we could still solve for this angle A by using the inverse cosine, because it takes the adjacent side over the hypotenuse. So adjacent was AC or CA over the hypotenuse. If we put in that ratio into the inverse cosine, we will also get the measure of angle A. And conversely, maybe we don't know the hypotenuse. We just know how big the opposite and adjacent side is. We could still find this angle by using inverse tangent. So again, it's a similar, you know, it depends on which sides you have, which trig function or inverse trig function we use to find the angle. So tangent was opposite, which is BC, over adjacent, which is AC. and that's the ratio we'd put in there to find the measure of angle A. Now, if we were doing measure of angle B, just like the regular trig functions, we got to relabel these sides and switch the opposite and adjacent and use those new labels. So here's an example 1. We'll do the same type of thing. Here, to find the measure of angle A, how do we set up the trig functions? You can maybe pause this and see if you can do it on your own and then watch the video, or just watch it through and see if you have any questions. So let's see, the first thing I'm going to do, it's with respect to angle A here. So I'll label my sides. Let me see if I did it. Here's the hypotenuse, yep. Opposite will be opposite angle A, the one we're doing for. And there's adjacent. So the measure of angle A will be found by taking the inverse sine of what? The side opposite, which is side SH here, over the hypotenuse, which is side AH. If we put those two links in there, it's going to output the measure of the angle. To use inverse tan, what? Tan is opposite, which is SH, over adjacent, AS. So if we put these two, the ratio of these two sides into the inverse tan, we'll also get out the measure of angle A. Depends on which ones you have to use. And then, of course, cosine is the side adjacent, which is AS in this picture, over the hypotenuse, and there it is. So try the quick check now, and then you'll go on to part 2 where I have the answers. Go ahead and try it first. Put in your answers. If you miss something, you'll just erase it, and if you've got any questions, let me know. This is the end of part 1 right now. Whoops.